This conference will now be recorded.
Hello all, welcome to the next session on SAP ABAP object orientation. And till today we have discussed what exactly the object orientation, and just we'll have what exactly the object orientation. What is object? Object is an instance of a class, and class is a reference to the object, and class contains the attributes, methods, and events, and also we have types, declarations, and methods will have the interfacing parameters, importing, exporting, and returning, and changing, and exceptions, right? And also we have discussed about the visibility sections of the class. That's an encapsulation. So that is public, private, and protected. Maybe I don't go inside, just high level overview, and that's what we have discussed. And also we have seen about the static and instance, and what exactly the static and instance, and what is the difference, how to call, where to call. And static is available in the entire session, and the object, we can have multiple objects for any one class. And there is a key is a unique identity for an application. Attribute is a property of an object, and also method is a function, and events is a status of an object, and exceptions we are going to raise the errors. And there is a class definition, and here we are going to define, and implementation, here we are going to implement. Okay, then so the difference of static and class. And also we have seen class instantiation. If it is an instance, definitely you need to instantiate, then access your attributes and methods. If it is in a static, directly we can access your attributes and methods. Yes, that's one. And where we will use the actual concept next. ALV, whoops, we are going to use BAPI, we are going to use whoops. Workflows, we are going to use whoops. And WebDenko, we are going to use whoops. And totally Fiori, UEFI is designed with the object orientation, MVC architecture, and OData entire definitely more totally object orientation, and AMDP in object orientation, BADI object orientation. They all are key concepts. If you keep this in your resume, you are going to get any number of calls. And if you are able to explain this concept, definitely you will get the job. No one will stop you. Even God will not also not stop you. That's the power of these objects. And we have seen the differences: public, protected, and private. And and next one is attributes and local classes restricted for that program only. If you want to have a global visibility, if you want to access from the multiple programs, we need to go with the global class. And SE24 is the transaction base. And also there are two methods, default methods. One is the class constructor, and one is the constructor. Class constructor is a static method, and constructor is an instance method base. And in detail, you need to look out this PPT. And friends class, see, if you want to access the private attributes of another class, you should become a friends class. That's the name, friends class. And inheritance, and if you want to access the objects from the parent class or super class or base class objects into the child class objects, we are going to use the inheritance. That's the inheritance. Maybe this is my maybe the real-time implementation. The sales depends on the customer, the sales depends on the product. This is a surrounding object, and we are going to see the next one is we are going to see the inheritance, single inheritance, multiple inheritance. Single inheritance only possible with the classes, but multiple inheritance. So with class you cannot get the multiple inheritance. Just you can assign super class only one class, but if you go with the interface, I can inherit multiple interfaces. Yes, that's a multiple inheritance is possible with the interfacing. In the interface is an abstract class, and interface is an abstract class. It provides a multiple inheritance, and interface will have the definitions only. We don't have any implementations, and we cannot. It's an abstract class. It provides the contract between the caller and calling party. Okay, so interface components by default provides the public visibility cases. We cannot provide a encapsulation in the interface level. By default, it's in a public. Whatever you define, it's in a public. That's what interface. And BADI uses the interfacing concept. BADIs will use the interfacing concepts. And And also we cannot have constructors in the interface level. You cannot. And abstract also provides the inheritance, but at least there should be a one method, abstract method in the abstract class. So this is what. And casting, there are two casts, upcast and downcast. Child objects into the parent objects, it's an upcast. Parent object into the child objects is a downcast. Upcast, okay, maybe I confuse whether it is narrow or widening. Widening first, widening and narrow. Widening means upcast, narrow means downcast. This is the way I remember. Don't confuse. And field symbols, very, very important. So dynamic data objects, and it's a placeholder for an object, and also it provides a pointers to the object directly. Okay, when you change something directly, the value will be changed in the that pointer reference object. That's a field symbol, and we have used the field symbol heavily. Static means directly you can assign the table, it will take the static field symbol. But dynamic, type any table, type any, it's a dynamic. So whenever there is a dynamic, you need to handle with dynamic data objects. There is a data object, type ref to data. You need to handle with, and you need to do an assign component, and that kind of stuff we need to do by using. And the next concept we are going to do now. And now guys, so we are talking about object flight and all. So maybe today we will fly in the Roger guys. Today we will fly in the Roger. How we will fly in the Roger, I am going to show now. So we are going to fly in the sky in today's class. So how can we fly? That we'll see, and practically we will see it now. So yeah, this is my object. Maybe this is my flight. So the flight can be in a passenger flight. The flight can be in a goods, guys. So maybe I will do the flight stuff. Maybe I have a flight. Maybe exact term is the aeroplane, right? And maybe I have. So this is my interface. Interface. Okay. Now I am going to have another two things. One is the passenger airplane, and another one is goods. What is this? Technically, is cargo. Cargo airplane. Okay. So what I am going to do is, so tell me what is the common functionality between this and this. Tell me what is the common functionality between cargo plane and passenger plane. Fly, right? Fly is a common functionality. Yes. Fly is a common function. So tell me some of other functions of this. Landing also common. Both are same. Fly and landing. That's okay. Take off and landing. Both are same function. Okay. Pilot is an attribute. It's not a yes attribute. Pilot is required to fly the both the planes. Okay, it's an attribute I can say. Okay, wings are the attributes. Huh? Fuel is also an attribute. Signals, both the things required. It's an event. It's an event, the status of your object. So you need to convert technically it is signal. Okay, something it pass something you will get a return. It's a signal status of an object, right? Yeah, apply real things. What we can, some function you are missing. So I said passenger plane, cargo plane. Some function you are missing.
Passenger plane, passengers.
Ah, boarding, correct. That's the.
Cargo, goods and.
Yeah. So already you visit my class. No. Okay.
Already you got this.
Already I told that. Okay. Yeah. So boarding. Boarding here means passengers are getting boarded into the flight. Here cargo means goods are getting boarded. Guys. Okay. But the function is I can say it's a boarding, but the behavior is different here. Here, if the passengers will onboarded into the flight, but here the cargoes, the goods, and the freights are getting into the loaded to your planes. So the function, I can say it's the same kind of function. The behavior is different. The behavior is different. Maybe so I can define these things. So maybe it's my method, and it's my landing is my method, right? And pilot, maybe it's my attribute. Wings also, it's my attribute. And fuel also, it's my attribute. And event and boarding, this is my method, right? And also maybe I have an output. This is also common method. This is also one method, common method. Okay, save. Okay, this I'm going to implement now. I will implement the interface first, and my interface is so SE24 and GIF interface is IF. Okay, then it's my EDC7 underscore okay, and create the interface. So see the naming convention IF, by default it comes interface. If you put CL, it has. If you both that, then you need to select as a name, either it's an interface or class. That's aeroplane interface. Save, save. Yes. Yes. Maybe attributes will declare the things. Maybe attribute underscore. Okay, pilot. Okay, maybe I can give the pilot. It's my static. I can move static. Maybe it will change based on the things. So I can say it's an instance. Okay, it's not a fix. And maybe the pilot, I can say it's a name one place. Okay, maybe I can take the pilot name. Okay, next attribute underscore uh, wings. Okay, wings maybe it's a fixed static wings. So every flight will have fixed wings, right? So wings, what we can say is what we can do. Type. I need to go. Maybe I can take info. Okay, some number. Okay, some number I'm going to take it. And wings and fuel. Yeah, definitely the fuel is also same. Entity fuel, maybe it's my static attribute, and maybe the fuel also maybe same kind of fuel. Maybe I can say fuel, maybe I can do my name one. So it's a character. So I will take the characteristic. Maybe that's my attribute in the interface level, and go to the methods. Right? Maybe my method is one is my fly is my take off, and it's my um, instance method, and also maybe I can say it's my take off. And next one is maybe landing. I don't implement much methods. Maybe boarding. That's it. Boarding, and it's my instance method, and it's my okay boarding. Maybe same. This is my methods. Maybe output. Output. It's my instance. Output. Same. So I have only definitions. I define. Okay. Event also I don't define. Okay. This is my interface. Okay. Take this interface and go and implement one abstract class. I'm going to implement one abstract class and create and see. So it's a not CL and IF. it is asking whether it's a class or interface. I'm going to create an abstract class. Okay, this is my abstract class. Okay, and it should not be a final case even. So if it is final, you cannot inherit. The inheritance is not possible. So this is my abstract class. So if I want to inherit this into the child, so if it make it final, you cannot inherit into the child class. That's why I take out the final. Yeah, I can put maybe and save. That's it. And here in the inherited, I'm going to inherit this from my interface GIF underscore EDG7 underscore air, see aeroplane interface. And when you do this and save it and go to the attributes, and the attributes are inherited, and go to the methods are inherited, and save it. And one more thing is I can the common functionality is fly, and the output is my common functionality. So I can implement my common functionalities, and maybe you cannot redefine the double click it, and I'm going to implement. So fly, and I'm going to write something and write. We are going to fly in the great ocean. So this is my statement, guys. So we are flying now. Okay, with this function, we are in the sky, right? And we'll go back and maybe output. Why I have taken this out? Huh? Yeah, no, it's not required. Maybe I have a boarding, but boarding in terms of cargo it is different behavior. In terms of passenger it is different behavior. Leave it as it is. Maybe what I can do is to show something. So I am going to make this method as a final method, guys. This method is a final method. See, this method is my final method, and change. So what I did, selected this and I went to details. I make this method also in a final method. Okay. And next, this method boarding is my abstract method, because since it is an abstract class, I should have one method. It should be an abstracted method. Okay. And whenever you make abstract means I can take that method, the different behaviors I can make it with this method. Okay, the implementation I can implement in a different way in the different classes. So that's why, so that's my abstract class. Okay, just done. Take this abstract class, go to my class CL. It's my passenger aeroplane, PASS aeroplane. This is my double underscore passenger aeroplane. Now see, I am creating my passenger aeroplane, and I make this final. I'm going to make this class as a final. This one, see, save and save. So this class I'm going to make as a final class, and I'm going to inherit this from the abstracted class. See, single inheritance with the class GAC BDG7 underscore my play. That's it. Is it correct? Yeah. So this is my abstracted. I'm inheriting the passenger from the aeroplane, from the abstraction of aeroplane. And go to the attributes. You see, sorry, abstracted. Save maybe. Save it. Save. Now we come to and see. You can see. You need to save it and go to the methods. See, the fly method I have already implemented this. See, double click on it. It goes to the implementation and output actually. See guys, this method I make a final method in the abstract class. So let me try to implement this, and see guys, you cannot implement here. You cannot implement. It goes to the there only. It goes to the there only guys. Maybe is it change mode? No. Yeah. So it is going to there. Maybe I should not implemented that in that abstract method. If you don't implement, already I have implemented there. That's why it's going there. But if I don't implement there, here it is going to give me the error. Maybe I will do the redefinition. Redefine. See, final implemented method cannot be redefined. See, this is my final method. You cannot. This is all interview questions, guys. Okay, whatever I am explaining, every point is an interview question. Every point, final, abstract, everything is an interview question. Okay, so you cannot, if it is in a final method, you cannot implement in the child classes. That's the final method. And but my boarding method, see, I'm in a passenger plane and my boarding is different functionality. Maybe I can redefine this because it's an abstract method, and go and redefine this, and I can redefine this method, and my method is now, see, my method is right. Right. Passengers are getting loaded into aeroplane. Okay, this is my boarding method, and I will go to the, that's it, activate. So I implemented, see, in the passenger plane, passengers are getting boarded, or humans, I can say, humans are. Humans are getting boarded. Come back, and so this is implemented, so it comes in the this color, other things will come in the blue color base. So that means if you see any abstract class which is having black color, means that is implemented here. Maybe if you set filter, it will display only implemented method in this class. So other things will not be displayed. So take out filter, the other things are not implemented in this class. That's the filter. Maybe you see here three methods, but if you see the standard classes, and when you select this, you are going to see like this. What are the implemented methods in that class? Okay, like that we need to replace. The standard class, you can see 100 methods also inside the standard class. Here we have only three, so there is no difference you see. But if you see it like this, so here I can say 100 methods. If you want to see in the 100 methods which are implemented in this class, select this, that will be displayed over here. Okay, this is my passenger aeroplane, and I am going to do a cargo aeroplane now, and create cargo aeroplane. This is my cargo aeroplane, and make a final and save it, and, okay, and go to the properties, super class, and my super class is the abstracted class, and save it. And guys, lot of options here. Shared memory enabled. This is also one of the object, one of the task I need to explain. This is also very important class stuff which we will do in the real time. And this class should be in a final. And go to the attributes and see what happens. AC, enter, save. Yeah, maybe. Cargo aeroplane. What happened, guys? Is it? I think, yeah, yes, it is aeroplane. What happened then? Okay, attributes. Why it's not getting here? What happened? Maybe is it in? I think it's not in active mode. Double click again. Before it came, right? Yeah, it's active only. Why it's not coming in this class then? It's not a final. Yeah, my abstracted class. See, this is inherited. And this is used there. Maybe why it's not coming. My cargo plane, save it. AC EDG7 aeroplane. Yeah, this is the class. Go to the attribute Y method, save it. Maybe I will do the activation. See, I did some error, it is coming up. The definition of the method boarding is missing. Why it should be an abstract? It should not be abstract, right? Why I need to make this as an abstract? Did I make that abstract? SC24. No, wait. Is it this class is an abstract class? Change. It should not be abstract class. Public only. Here it is accepting attributes. Oh, I'm getting all. Huh? Okay, I think perfect. I think yeah, perfect. Okay, it should not be abstract classes. See what I mentioned the in the abstract class. I gave one definition. We cannot instantiate the abstract classes. Whatever this, it should be the final thing should be not a abstracted one. The final thing should not be an abstracted one. Go to the cargo class and boarding and select the boarding and redefine the boarding here. Yes. Since it is an abstract method, you should redefine this method. That's what it is giving. And right and freights are goods. Both are same ways. Freights are goods are getting boarded into cargo airplanes. That's it. This is my implementation. Okay, simple. And save it and activate the class. Okay, done. So my objects are ready. And maybe what I am going to try to do is maybe this is my class and I am going to inherit underscore final and create my class, and this is my class, and save and okay, and go to the properties and go to the super class. I'm going to inherit the cargo plane into the another class and trying save, and the aeroplane class, the cargo aeroplane is in a final, it cannot be have subclasses. That's the final class. That's the final class. Final. We cannot inherit class into the subclasses of child classes. See guys, if you read this, you will get this theory in the internet, but you don't understand. But when you implement, so you can permanently remember this kind of concepts. Okay, this is my final class, right? Maybe final is done, and just to show the final thing, I did this case. I don't want this. Okay, just to show that error message, I did this. Okay, back. Now I am going to create one report. SE38 GEDG7. It's my aeroplane report. This is my aeroplane report, and create and export our program and save it. And 7 save it. Transport for ABAP, and this is my thing. And I have two radio buttons parameters. One is the P passenger aeroplane and type sorry radio button group GRB1, and I have another radio button. It's my P underscore cargo. Yeah, cargo correct here. So I forgot that. It's my GRB1, and maybe we need to have user command. It's my UC1. Okay, and that's it. I have two radio buttons and activate. This is my input for my program. I always design my input, and now to I will provide the text elements and selection text, and it's my okay, it's my cargo airplane. It's my airplane. Passenger. That's it. Okay, activate. I've activated my report and come back, and maybe I will use the okay. We are not using much now. Sort of selection. Okay, the sort of selection. I'm going to write two things, guys. One is if it is my passenger aeroplane. If this is my passenger aeroplane, I will do one functionality. Else, if it is my P underscore cargo is not initial, I will do some code. I will do some yeah, and end. Okay, guys. Since we have only two options, I can write else also here. Got it? So that's what you need to understand. Huh? So what I am putting the condition here, but you can use the else. Why? Because I have only two selections. But if you have three selections, the else doesn't work. You need to put else if like that. Okay? So that's the flow you need to understand. Huh? So create a printer and maybe yeah. So what I am going to do is I am going to create an object case, and my object is data inline declarations. Okay, it's my geo underscore my passenger. This is my whenever it is passenger, I am going to instantiate the passenger object, and it's my all new guys. Not I don't use the create object. I am using the new, and my class is GCL underscore. What is our class? GCL underscore EDG7 underscore EASS to the control space. Yes, I did this. I'm going to do again control space, control space. Nothing is there. If the constructor is there, you will get the this space. You something I am doing wrong. Do the yes, yeah. So that thing I am missing. So if there is a constructor, it will ask for the input parameter key, but there is no constructor. That's why it's giving me the blank. So that's what we need to understand. Yes, I have instantiated my object, and see, guys, I am doing now. So this is my child class object. Okay, maybe this abstract I cannot have an instantiation, and my parent is the interface. I can assign my child class object into the parent class object, and my maybe interface case always. So I need to declare one. If I don't declare, if I use the inline declarations, yesterday we have seen the problem. See, if I do like this, gif underscore my airplane. Okay, if I do like this, what happens? Geo underscore PASS. Suppose if I do like this, what will happen? So this object is referenced with this class, and same attributes will be passed to the interface level. I don't want to do like that. So maybe I do like this. I define this object, data definition. the interface. Data by GIF. So always doesn't work as inline declarations. You need to cleverly use the inline declaration. GIF underscore airplane and type ref2 and GIF underscore EDG7 control space. Okay. Yeah. EDG7 control space. Yeah. Is it? Yes. That's it. Okay. Now, see guys. Now this is my parent. This is my child. I am assigning the child into the parent. This is what caste. Uh, okay. See guys. And next. So I am assigned to here. The same way if it is a cargo, do the same stuff.
Here we use gate.
Huh?
This is let us use gate. Data.
Yeah, yeah, okay. I will do that now. Simple, whatever it is. Uh, Create object. Okay. If I use create object, my object, can I use data declaration? Yes. Create object data. No, it's not possible, guys. If I use create object, definitely I need to do a data declaration. Okay, I'm doing a data declaration, and it's my geo underscore cargo, right? Cargo. It's my type ref2 my GCL underscore EDG7 underscore CA ROA. So first you have to declare the data object. Then you must instantiate the object. So this is the second way to the control space enter, right? That's it. And maybe, yeah, so it's not a direct class, that's why it's using, it's not required. A different. And now it should be in a cargo. I am assigning the cargo things. I am assigning the cargo things. And save and edit. Now I can use this. Okay. Whether it is just I will use GIF. Okay. Maybe call method. Okay. Call method. My GIF underscore airplane and my method is do this. What method you want? You want boarding or fly? Yes, first board, then fly, right? First board and then fly. And this is my boarding. And another method is call method after boarding GIF underscore airplane and then this and maybe it's fly. Control space, that's it. Okay. Now 3D printer and execute. See guys, passenger aeroplane, execute. See, humans are getting boarded into the aeroplane and we are going to fly in the airborne journeys. So humans are, if it's in a passenger plane, and cargo plane and flights are getting boarded into the cargo aeroplane and we are going to fly in the, not way, actually. Okay, that's it. And guys, so which method I have used? This is my method, one method, save method, and if I select passenger aeroplane, it gives me the humans are getting boarded. That's my result. If I use the same method, the implementation in the cargo aeroplane, so when I select cargo aeroplane, it gives me the result. The flights are getting boarded into the aeroplane. The same method, this is my same method, I use same method. Okay, same method behaves differently in different classes. It's my uh, more. This is the polymorphism concept. Same method behaves differently in different classes. So this class, a cargo class, the behavior is different, and the passenger class, the behavior is the different case. It's my polymorphism concept.
This is differs in implementation.
Huh?
Differs in implementation.
Yeah, so that's it. It behaves differently in different classes. The implementation is different. Okay, so that's my Control C. This is my, maybe I have space on there. Yes. So this is my, guys, if you want to achieve the polymorphism, how can we achieve? That's what my question is. I don't ask the definition. So how you can achieve this? That's my question. So if you want to achieve the polymorphism, you need to have interface, you need to have abstract class, then only you can achieve the polymorphism, guys. Okay? So this is the my statement. Without that, you cannot achieve it. Without that, you cannot achieve it, guys. So uh, prerequisite for the polymorphism, we should have interface and class. So first thing, you implement the interface, then abstract class, and the different behavior you should get in the different classes, the child classes. That's all. Today's topic, and we'll see in that tomorrow's class the different concepts. Maybe, huh?
It is downcasting. This program.
Which one? Upcast only, both upcast. If I do like this, it's a downcast. Uh, Maybe my GO underscore PASS is equal to the GIF underscore arrow plane. So if I do like this is my parent object, this is my child object. If I assign my parent object into the child object, it's a down casting. Down casting or narrow casting. That's it. And we'll see the remaining things, maybe exception class, persistent class, singleton factory, overall of things are there. Okay, it's a ocean object orientation is an ocean. Okay, so we have discussed a lot, and so I say these are all the fundamentals for an ABAP base. It's not advanced. It's a fundamentals for the ABAP nowadays. It's a fundamentals. That's why still you are in the fundamentals only. Okay, so that's it for today. Thank you. Bye bye. See you tomorrow, guys. I will give the exercise on this, and you need to use the field symbols, and you need to implement the with the real data now. Okay, so I have one order interface. Okay, in this order interface, I have get, already I have given same exercise, and I have um, uh, I have this. I have two methods: get orders and output. ALV output is on method. ALV underscore output. These two methods, guys. Okay, simple. And I have a same design. I have an abstract class. I have an abstract class for the orders. And in this common functionalities, the output functionality is same way. So ALV output is my common functionality. Implement here itself. Implement here itself. But the importing parameter you need to take. Importing parameter is my output underscore data, and which is a type standard table, guys. Why? Because it's a dynamic. Okay, if it is in a purchase, I should display purchase orders. If it is in a sales, I should display the sales orders. It should be in a dynamic. Okay, and maybe this is my get orders, and yeah, so this is my thing. Maybe guys, importing, where you will define this importing the importing should be defined here, guys, because the definitions should be done in the interface level, not the implementations. Huh? So the definition should be done over here. So for this output data is my importing. This is my database. Okay, maybe I will take the data. I will display in the output. That's it. I don't give any exporting. But instead of get orders, maybe get orders. Maybe I have importing. Not a KOD. I will give it a different logic. MAT NR is material. So material can have sales, material can have purchase orders. That's why I give an importing as material. Here also the output should be importing this, and exporting should be also in a dynamic, because you don't know whether it is in a sales or sales or purchase. It should be in a standard table. It should be in a standard table. Okay, this is my definition. Now I have two classes. One is the sales class, and implement the method get orders. Only get orders from OOABAP, guys. The relation is the OOABAP, because the material will be available in the OOABAP. Get the orders from the OOABAP and control C, and it's my purchase class. Yours class. Purchase. What is the table? Huh? is the items. That's it. Okay. So dynamic, you need to use with the field symbols. Okay. Dynamically, you need to create the internal tables. Okay. And report, you need to create one report. Two radio buttons: purchase and sales. Purchase and sales, and the input is the material number. If material number is an input field, and two radio buttons: purchase and sales. I enter the material. If I select sales, it should display the sales order item. When I select purchase, it should display the purchase order items. Simple. And with the interface abstract class and polymorphism and the casting is the combinations. Okay, that's it for today. Thank you. See you tomorrow. Bye bye.